Hi folks, these are the suggested problems from homework number 4, which is coming from section 2.3 of the book. Now what I have done here, this box that you see here, which is surrounded by red rectangle, is a direct cutout from the textbook. Okay, so what it says, let me first let me get my pen here going. See, okay, red, that's good. All right, so if you have an expression which is a sine kx or a cosine kx, a is called the amplitude, okay, and you can find the period of this function based on k. The period of this function is 2 pi divided by k, where k is a positive number. Okay, so in order to plot this function, all you need to do is to do it between 0 and 2 pi over k, because it keeps repeating itself, whatever you have in that interval. Okay, so let's start doing some problems here. We first get rid of these. All right. All right. Okay. My first problem is what you see here. It says, suppose that y is equal to 3 sine of 2x. What is the amplitude? Well, the amplitude is the thing that's multiplied by the sine or cosine, as you can see here, right there. So the answer here is 3, and the period comes from this value. This value k is 2, so the period is 2 pi over k, which means 2 pi over 2, which is pi. The period is pi. Okay, let me erase these. We don't need it. All right. All right, then we are asked to plot a bunch of trig functions. So for example, let's start with this. We discussed this thing in class. This is an upward shift. So if you draw sine of x is going to look like this. And of course it's repeating itself, but I'm not drawing the rest of the repeat here. Okay, so it is going period 2 pi, obviously. And when you have 3 plus it, all that means is that every point is shifted up by 3 units. So remember, this goes between 1 and -1 as far as the height goes. Here is x, here is y, and if we were to draw this thing, if we were to draw 3 plus sine of x, you just take this thing and shift it up by 3 units. So this will be effectively 4, and everything is up by 3 units. Okay, so this is the amount of vertical shift. Okay, let's do number 6. Okay, so number 6. All right, this was first problem. Problem number 6. This was by coincidence 4 here. Okay, now first of all, you see a negative cosine of x. Okay, so you draw the cosine and then reflect it with respect to x-axis. Remember, when you draw cosine, cosine is just like a sine except that it's shifted by 90 degrees. But anyway, so it looks like that. So this is 0, this is 2 pi, here is pi, etc. And then when you say negative of that, that means it's shifted down. It's shifted down, which means that, let me use a different color here, say blue. So everything is reflected like this, okay? And then because you're adding 2 to it, you raise the whole thing by 2. So remember, this is a 1, this is a minus 1. So you raise everything by 2, so this point goes to that point. This point goes to 3. Let me use a different color here. Okay, so it's going to look like this. Everything is shifted up by 2 units. Etc. Now I only draw it in the interval that I need to because it's periodic. So the resulting graph is this. Okay, and then it keeps going on and on and on. So this minus sign told you draw cosine, and that's the red one, and mirror it with respect to the x-axis. This is the x-axis. Okay, so you get the blue one, and then the plus 2 means that raise everything up by 2 units. We have to make sure that we can do these things with our calculator too. So at least in this video segment, I will just do it manually unless I have to, and then in the class or you yourself make sure that you can actually do it with the calculator. Okay, let's do another one. How about number 8? Number 8. Okay, so first you draw cosine of x, and then you shift it down by 1 unit. Okay, so let me do number 8 here. There is number 8. Let me draw first cosine of x. Cosine of x looks like that, right? Between 0 and 2 pi, it looks like this. Okay, so then you shift it down by 1 unit. Remember, this is 1. You shift everything down by 1 unit, so you're going to get something like this. So that point goes to this point, this point, I'm sorry, this point goes to this point. Terrible. Let me erase this for you. Right. Read again. Right here. Now red. So this goes down by 1. This goes down by 1 here. So this point goes to that point. This point goes down by 1. So when I do this thing, I get the following curve. See how everything is shifted down by 1 unit? And then of course it repeats itself because the period is 2 pi, etc. Okay, so the red curve is the graph of number 8. Alright, what else have we got here? Number 10. Number 10, you took the sine and you multiplied by 2. That is the stretching in the vertical direction by 2 units. Multiplication by scalar basically becomes stretching. So here's the situation. This is number 10. So first you draw sine of x. Remember sine of x like this. 0, pi, 2 pi. Of course, it repeats itself, right? So when you have 2 sine of x, 2 times sine of x, this side is 1, this side is minus 1, minus 1. Everything is stretched in the vertical direction by 2 units. By a factor of 2, not by 2 units, by a factor of 2. So this goes to 2. This stays at z. So what I mean is that this goes to 2. That's what I meant. Let me erase that for you. Okay, good. So yeah. So this go multiplied by 2. Of course, you multiply. I didn't mean that. So let me see. Red one. I'm sorry. This is the graph. This is the graph of sine of x. You can see right there. Okay. So this point multiplied by 2, you get 0. This point you multiply by 2, you get 2. This is height 1. This point, other point. Let me see for a second. This was a pi. Okay, this was a pi. You multiply it by 2, you get 0. Okay. 2 times 0 is 0, right? 2 times 1 is 1. This one is minus 1. You multiply it by 2, you get minus 2. So you get like that. All right. And this is height 0 multiplied by 2, you get height 0. The bottom line is that it's the stretched version of the original red curve in the vertical direction by a factor of 2. Right? Everything is stretched, and of course when it goes to the rest of the interval, it repeats itself. Okay? Notice that every time you have a y, you multiply it by 2. So these are supposed to be horrible picture, but these are stretched by a factor of 2. This is not shifting, it's stretching. Okay? Alright, what else do we have here? We have number 12, minus 2 over 3 cosine of x. Number 12. Alright, minus number 12 here. Y equal to minus 2 over 3 cosine of x. So the first thing that you do is you draw cosine of x. Okay? Cosine of x. There is cosine of x. It looks like this. Right? Period 2 pi. This is 0. This is 2 pi. This is pi. This height is minus 1. This height is 1. And of course it repeats itself, right? So I'm not going to draw the repeaters. Well, first of all, there's two ways to do this. One is to notice that, first of all, every height is squished by a factor of 2/3. So for example, let me do it in different colors here. For example, let's do this piece first. Okay. Let's do this piece first. This piece. So without the minus sign, okay? So this goes to 2/3. 2/3 is roughly here. And then everything is going 2/3, factor of 2/3. Of course, this is 0, so it doesn't go anywhere. It stays there. So this was minus 1. Remember this was minus 1? So it goes to minus 2/3. This was 2/3. So every height is squished by a factor of 2/3. So 2/3 of cosine of x is going to look like this. But then I have a minus sign here. The minus sign means that they're all reflected. Every height of the 2/3 cosine of x becomes negative of the same thing. So let me draw the final curve as the red one. It's the reflection of that green curve with respect to the x-axis. So if you repeated that, it keeps going this way and it keeps doing that way. But you can see the minus 2/3 cosine of x is like this, and it keeps going on and on and on. Okay? This is the answer, minus 2/3 cosine of x. Okay, let's do the one. What's the next one? We did this. How about 4 minus 2 sine of x? Okay, this is 4 minus 2 sine of x. The x is dropped from here. Number 14. Number 14. Y is equal to 4 minus 2 sine of x. Is that right? Yeah. Okay. So what we're going to do is first we're going to draw sine of x. First we're going to draw this. Okay. So let me do it like that. And I do only the interval 0 to 2 pi because it repeats itself. There. And then you have 2 sine of x. You have this, right? So every height is stretched by a factor of 2. Let me use a different color here. So for example, how about using blue? Okay. So this was a height 1. Remember, this was a height 1. And this is a height minus 1. Every height is multiplied by 2. So this point, of course, is 0, doesn't go anywhere. But this point that you see here has a height 1. It goes to height 2. Okay. So the 2 sine of x is going to look like this. It's just like sine of x, except that everything is stretched by a factor of 2. So this blue one, the blue one right here is 2 sine of x. But I have a minus sign here, minus 2 sine of x. So what that means is that all the heights are now becoming the opposite sign. So if you have a positive height in the blue, it becomes negative. If you have a negative height with the blue, it becomes positive. So let's do that. The green one is going to be the mirror of the blue one with respect to the x-axis, like this. This green one is minus 2 sine of x. Okay? And finally, you have a plus 4. That means everything is shifted up by a factor of 4. So let me do the following. Since I want to do a good job on drawing this thing, what I'm going to do is the following. I'm going to move this thing down, erase the stuff that I don't want. Okay, so I'm going to erase this stuff. Everything is shifted by a factor of 4. Okay, so what does that mean? Okay, so here's my axis. Here's my axis. The green one is shifted up by 4. So this point goes to 4. This is 2 and this is 4. This red one that I'm drawing for you is going to be the final graph. Everything is shifted up by 4. Remember, this was 2, so this goes here. This was 0, so it goes to 4 right up there. This was 0, it goes to 4. This green one here is remember, it's minus 2. When you shift it up by 4, it goes there. So there we are. It's this. Take the green one, visualize it as being shifted up by 4, right there. Right there. And then, of course, it's going to repeat. Please make sure that you can reproduce these graphs with your calculator. Okay? This is the best way of checking your work. Okay? I started with the small red one, the regular sine of x, stretched it with the blue one factor of 2 up and down, of course. Multiplied by minus, everything got flipped. I got this green one, and then every point on the green one is raised by a factor of 4 units. Okay, so that's what happened. Now this last one, let me do this. H of x, so I'm going to erase some of the stuff. What is it? This is number 16 we're talking about. 16. Let me erase these. Remove this. Okay. 16 is, it says, what is it? 2 sine of, or absolute value of sine of x. Absolute value of sine of x. So this is my y. So it's very simple. What you do is you draw sine of x. Sine of x looks like this. Right? This is sine of x. And of course on this side, it repeats, etc. So let me erase this thing on the side of this. On the side here too. So I'm going to erase this. Okay, good. Good. So now we want absolute value of that. Absolute value of that means that anytime you have a negative value, make it positive. So the graph that you see is this. Absolute value of sine of x looks like that. Something wrong with this pointer. So basically it's all these humps except that they're up. This blue one is absolute value of sine of x. All right. So this is the video segment 1. Let's go ahead and do this, and then I'll do this problem and then stop it and do the second video. Okay, good. So let's see now. All right. Find the amplitude and period of the function and sketch the graph. Let's do 18. 18. First of all, the amplitude is whatever is multiplied here, except that don't take it to be negative. Take the positive, okay? Usually amplitude is assumed to be a positive number. Therefore, you can think about this thing as 1 times sine of 2x. And k is 2. K is this number. So the period is 2 pi over k, which is equal to 2 pi over 2, which is pi. So if I were to plot this thing from 0 to pi, okay, first notice that if I had y equal to 1 sine of 2x, not negative, 1 sine of 2x, then it would be a single sine wave fit in here with the amplitude of 1, a equal to 1. Okay, so what you see there is actually sine of 2x, not negative sine of 2x. If you want the negative sine of 2x, and that's really what I want, then it's every height is negative of the height that I have here. So the graph of negative sine of 2x is going to look like this. Okay, let me draw it here. How about that? 0 to pi, okay, like this. And then it repeats. Okay, so that takes care of number 18. Let's go ahead and do number 20. Let me write it here. So y is equal to 1/2 of cosine of 4x. 1/2 of cosine of 4x. Okay. So this number is the amplitude. It's a positive number. A is equal to 1/2. And k is 4, which means period is equal to 2 pi over 4, which which is pi over 2. So within the interval 0 to pi over 2, you can fit everything that you want. So 0 to pi over 2, suppose this is pi over 2, you fit a cosine. Okay, it's going to go like that. Height of 1. Except that the height of the actual curve is 1/2. What I have here is actually y equal to cosine of 4x. It is not 1/2. So because there's a 1/2 here, you take all these heights and you shrink it in the vertical direction by a factor of 1/2. So for example, let me use a different color here. I'll use this blue. So this point is going to go to 1/2. This is 0, it stays 0. This point is -1, it goes to -1/2, and there we are. And this thing repeats itself, okay? So if I wanted to draw it down here, oops. So if I wanted to draw it down there, where is it? Oh yeah. Okay, so let me make this thing bigger. Where did it go? Yeah, right here. So this is 1/2. I don't know, something happened here. Something happened with my oh, maybe, okay, so maybe, how do I delete this? Okay guys, listen, I'm going to stop here, and then the second video we're going to do the rest of this, okay? So number 20, something went wrong with my